3.
Hello everyone, welcome back to our Dynamics Project 2. This time we are going to be creating a project dealing with pulleys. I'm here myself, Kevin, joined by Mariah and Jessica, and we are the A1 team. So for this project, we were told to create a pulley system involving at least 2 pulleys and at least 2 different masses. And upon that, we were also told to make some assumptions just to make the problems and equations a bit more easier. And for our project, we decided to do a elevator pulley system since elevators actually do use pulleys. We designed the elevator pulley system. Can you go to the next slide, please? So this is our diagram. As you can see, we have 2 pulleys, we have 2 cables, and 2 different masses. Um, Basically, this elevator pulley system is kind of like in a robot example when a motor shuts off and you're just relying on the pulleys to move the elevator. So for each student, mass 1 and mass 2 were different, and using those 2 different masses and the tensions and Newton's equations, um, we are going to be calculating some kinematic equations, solving for the object's position after 1 second and the object's position after moving 1 meter. Next, please.
Here we have our problem statement, and we wrote, for our pulley system project consisting of an elevator, each student will calculate each object's speed as they vary with time or position after being released from rest. We will be calculating these unknown variables using Newton's second law and kinematics.
Okay, so here we have the pulley system. At the very top, I wrote what was given, and I also wrote some kinematic equations using the position, and then the first derivative of position, which gives me velocity, first derivative of velocity giving me acceleration. Using these known variables, I was able to draw 2 free body diagrams. As you can see, for mass 1 and mass 2, I used Newton's sum of forces in the y direction, and it gave me 2 unknown equations. So I basically just solved for the unknown variable, plugged it in, and I was able to calculate the acceleration. And with the acceleration, I was able to plug it into the first kinematic equation, velocity final equals velocity initial plus acceleration times time. So we are looking for the final velocity. We know the acceleration and the time and the initial velocity. So that's how we got the final velocity of 2.58 meters per second. And then we jumped into another kinematic equation that's derived of using all 3 kinematic equations of position, velocity, acceleration. We could see that the derivative of velocity is equal to acceleration with respect to distance. And as we integrate, we are able to find the velocity using a position known variable. So these are just 2 methods to finding different velocities, either using position or time.
And then here we have the calculations for like a different scenario where a person weighs 52 kilograms and has a suitcase with a weight of 9 kilograms. Those get added together to become mass 1, and mass 2 here was 18 kilograms. Now following through with the calculations, we see that final velocity equal to 5.33 meters per second, and velocity equal to 3.26 meters per second.
So for this scenario here, we had 2 people weighing at 40 kilograms. each. So we were able to add those together to get mass 1. And then for mass 2, it was equal to 26 kilograms. And then using those same kinematic equations, we were able to determine that the final velocity is equal to 4.99 meters per second, or the velocity was equal to 3.16 meters per second. Just to wrap up our presentation for project 2, our group was able to determine each object speed of the elevator after starting from rest. Each group member used different weights of the objects, but used constant time of 1 second to get these final results. Thank you guys, and see you for project 3.